Hello. Now I am going to start the solution of query 1 and query 2. So this is the query you have. Transform the vector b equal to zax plus 1 minus x ay plus y over x az into cylindrical coordinates. So firstly we know that Cartesian coordinate system we have x equal to r cos phi, y equal to r sin phi, z equal to z. So this is the Cartesian coordinates, and in cylindrical coordinates we know that this is r equal to under root x square plus y square. Here I am just representing this. You have seen that in cylindrical we take rho, but in this numerical you can consider this as r. It doesn't matter what you represent. There are so many books which represent this as rho or as r. So r equal to under root x square plus y square tan phi equal to y over x and z equal to z. This is cylindrical coordinates. Hence the vector b can be written after changing the variable. Now you can change the variable in that vector b equal to zax plus 1 minus r cos phi unit vector ay plus tan phi az. You can consider this equation 1. Now by equation we know that this is in cylindrical coordinates vector a equal to ax cos phi plus ay sin phi unit vector ar plus minus ax sin phi plus ay cos phi unit vector a phi plus az unit vector az. So we know that the complete expression for a vector in cylindrical coordinate is this. So this is equation 2. Now you can compare equation 1 and 2. So after comparing it, we have ax equal to z, ay equal to 1 minus r cos phi, and az equal to tan phi. Hence changing the component in equation 2 by equation 3, just put these components of equation 3 in equation 2, you will get vector a equal to z cos phi plus 1 minus r cos phi sin phi unit vector ar plus in bracket minus z sin phi plus in bracket 1 minus r cos phi bracket close cos phi and this square bracket close unit vector a phi plus tan phi unit vector az. So after solving this, z cos phi plus sin phi minus r cos phi sin phi unit vector ar plus in bracket minus z sin phi plus cos phi minus r cos square phi unit vector a phi plus tan phi unit vector az. So this is the solution. Now we have this Cartesian coordinates into a cylindrical coordinates. This is the transformation actually from Cartesian to cylindrical coordinate system. Now query 2 is transform this vector a equal to yax plus unit vector ay plus x square divided by under root x square plus y square unit vector az from Cartesian coordinate to cylindrical coordinates. So now this is the solution. We know that in Cartesian coordinates x equal to r cos phi, y equal to r sin phi, and r equal to, you can write it as x square plus y square. So now changing the variable of vector a, we get this vector yax plus xay plus x square under root x square plus y square. You can write it as r sin phi unit vector ax plus r cos phi unit vector ay plus r square cos square divided by under root r square cos square phi plus r square sin square phi unit vector az. So we have this vector a equal to r sin phi plus r cos phi unit vector ay plus r cos square phi unit vector az. The complete equation in cylindrical coordinate is, we know that ax cos phi plus ay sin phi unit vector ar plus in bracket minus ax sin phi plus ay cos phi unit vector ar plus az unit vector az. This is equation 2. Now comparing equation 1 and 2, you can write ax equal to r sin phi, ay equal to r cos phi, and az equal to r cos square phi. This is equation 3. Now putting this equation 3 into equation 2, then you have to put this value of ax r sin phi in this equation, value of ay in this equation. Then you will get vector a equal to r sin phi cos phi plus r cos phi sin phi, unit vector ar plus in bracket minus r sin phi plus r cos phi unit vector a phi plus r cos square phi unit vector az. So you will get, after solving this, 2r sin phi cos phi unit vector ar plus r cos square phi minus r sin square phi unit vector a phi plus r cos square phi unit vector az.